Hey everybody, so welcome to the Lab 10 walkthrough. So this is what we would have been looking at in lab if we hadn't been shut down due to this COVID-19 global pandemic. Um, so yeah, let's get cracking on this. So first, we have the most basal lineages of the mollusks here. We've got the Polyplacophores, commonly referred to as chitons. This is a mossy chitin. If you've ever been to any of the tide pools down in all of our local shores, you'll see these things are everywhere. Easy way to identify them, there are 7 to 8 of these segmented or articulating plates. Right? So when they're flat against the rock surface, that's really all you'll see that look like this. Right? Here's another one. We got a spiny chitin. There are tons and tons of different kinds out there, but they also have the same general body plan, these segmented shells, and then all the fleshy bits are on the underside. There's another one, the Nuttall's chitin. Now, one of the things that it talks about in your lab manual, which you would have seen up close if we had them in front of you, is when they're smushed up against a rock, they're very flat and very, very, very hard to remove. Like, they are super hard to remove without a lot of effort. However, if they get pulled off of them for some reason, one of the reasons this articulating shell is very useful is that it allows them to curl into a ball, similar to like an armadillo or a pill bug, which we'll look at when we get to the terrestrial arthropods. So you can see kind of different stages here. If you pull it off, it just slowly curls itself up because that fleshy mantle and all that visceral mass is exposed, but that super hard plate is very hard to punch through. So you'll see it would go through. Let's see. So step one, right? It just kind of curls around. Step two, and then by the time you're done, you get over here with step three, and it's just this hard, impenetrable ball of shells until it feels safe enough to unfurl itself and stick onto something else. Moving on from the Polyplacophores, we've got the limpets. So again, super common if you've ever been under the tide pools. You'll see the limpets everywhere. There's a couple of different kinds on the outside. From the outside, when they're sticking to the rocks, they'll look like this. All right, that's usually what you'll see. But if you were to flip them over, again, very hard to do because they adhere to those rocks very, very well. That prevents them from being eaten because you can see this big fleshy bit on the bottom. It's very tasty for that sort of thing. But also, they live in the tide pool, so they're exposed for portions of their life. And so they need to prevent desiccation, drying out. And if you can make a nice suction seal of the rock, you can keep all the water in. Now, one of the things that you would have noticed if you look out in the lab, we put limpets on glass slides so that way they can do their adhering and sticking to stuff, but we can see underneath of them. What you want to take note is that you'll see this feathery-like structure right in the middle here. Right? So that is the gill. It's just what it is. It's a gill. It helps it breathe. You've got these chemoreceptors around the outside of these little tentacles. Right? They're not a nose, but they're just chemoreceptors. It kind of helps identify predators and prey and whatever it needs to go around. And then it's got these cephalic tentacles, right? So it's cephalohead, so it's the tentacles coming off of its head. And that's just how it, that's what it is. One of the other things that it's really known for is that it's got this. So here's the head region, circled in red. You'll notice that it's got this mantle cavity, which, if you remember the general body plan of the mollusks, there's a mantle cavity, and then that's where its head is and stuff, and then the visceral mass is inside of there, and then the mantle can be found inside, and the mantle is what is excreting that shell, and then the shell is on the outside. It's the shell. It's the hard bit that protects it from everything else. When you look up close, you've got the close-up of the mouth. So we zoomed in really close there. This is going to house the radula, which is another apomorphy for all of the mollusks. And we were really I was able to get a really good shot of this in the lab before they shut the building down. So, radula in action. So this radula in action, you'll see just how impressive it is. And the teeth are composed of this stuff called goethite. So it's an iron-based mineral. It is one of, if not one of the hardest naturally occurring substances on the planet. It's got a tensile strength stronger than spider silk. And you can see how that thing just kind of flips out and it scrapes whatever it wants to off of these rocks. So that's going right like that. Right? So that is the radula in action of a limpet. Other gastropods, so gastropods that you're going to be familiar with, the common land snail. Not all gastropods, obviously, are going to be marine. These are super common. In the area, Helix is just common variety garden snail. But if again, we're looking at one of those apomorphies, they have that the radula, which is common to all the mollusks. So if you were to zoom in, like we did on the limpet, and you had slides of this, so this rasp-like teeth. So this is the radula from the helix, from that land snail. It's just, again, super sharp little teeth. It's not as intense in terms of toughness as the limpets are. They're a source of great fascination. But again, rasp-like teeth used for scraping everything. And again, if we're going to start looking at these names and what they mean, gastropoda, right? It's a snail. It's a stomach. Gastropoda feet. It is a stomach on a feet. That's it. Moving on from there, some of the other gastropods, we got the nudibranchs. These are super cool. They're sea slugs. So what we've got here is a Spanish shawl. They are part of the Aelid nudibranch families, all right? Meaning that if you recall last time we were in lab and you got to see all those corals and the cnidarians and the things with the nematocytes that were the stinging cells. So these are the creatures that go through there and they eat all those stinging cells, but they don't digest them. They incorporate them into their serrato, these feathery structures on their backs, and use them for defense. And you'll notice they are very brightly colored. This is aposematic or warning coloration. Remember that term. And they're advertising. So if you're not trying to hide, if you're the small little squishy slug and you're not hiding and you're advertising your presence, you're warning things, do not eat me, do not attack me. It will be a very bad day for you if you do. So aposematic or warning coloration is a coloration pattern you're going to see throughout the animal kingdom. Think poison arrow frogs or brightly colored snakes like coral snakes and stuff like that. But warning, stay away. It's not going to be worth your time. Have a bad day. So this is the Spanish shawl nudibranch. Oh. Okay, so there's going to be there's a video on there for nudibranchs. Please watch that. We've had lots of them for you to look at. They're really good. Please watch the muscle dissection video. The link should be on Blackboard, and you need to go access it through the link. That way I know you've actually watched the video because we can do tracking through there. There will be some secondary videos about close-ups. So after they do the muscle dissection, we took it over to the dissecting scope, and so you can see up close the gills action going on, moving the carmine for that gill filter feeding. And then also it moves along the gills, and then the palps ball it up and it'd be shutting into the mouth if it wasn't dissected. Now we're moving on to the cephalopods. So again, looking at the name, cephala, head, poda, so head and feet. The chambered nautilus is the only current genus of cephalopods that has an external shell. So very, basal for these guys. They are, they got fossil records, these things going back millions of years. But that septate shell, again, that word septate, like we saw with the septate hyphal strands, it just means that it's, delineated. You can see things going on there. and they got the thing for buoyancy, help it control where it's going. It's got lots and lots of tentacles. Not a fixed number, depending on what you're looking at. Moving on from the chambered nautilus, we have the squid dissection. Again, the video link, you can either watch the video on Blackboard or click through the link on YouTube, whichever is going to be more convenient, but make sure you do it through one of those two sites. And that way I can track to make sure that you've actually clicked through there, because it'll let me know who's clicked onto the link or who has watched the video on Blackboard. Please let me know if Blackboard videos have an issue playing, and I won't put any more on there. I'll just do only YouTube links, or let me know if you can't see them on YouTube or whatnot. But again, watch the squid dissection video, which I would have been doing in class, but obviously we can't. Now, for the squid dissection, one of the cool things we do is we remove the beak and the radula from the squid, and we put that onto a slide, and what you see is it's called a beak for a reason, right? Because it looks like a bird beak, right? And it is this little hard thing inside that it uses it to rip off stuff. But here you see the radula, right? Now I'm going to, next couple of slides, we zoomed in, zooming in. So that radula, right, there's a recurring theme here, a rasping-like structure that it uses to scrape things off. So let's see if I can erase all that. Good. So zoom in on the beak, right? It looks like a raptor beak, but you know, slightly less hard than a falcon or something. Right? Then we zoom in on the radula more, and you can see that structure, right? It is, there we go up to 400. Sorry, not 400. This is at 100 magnification. You can see that real raspy tooth-like structure at different focal points here and here. Right? That was one that was just freshly removed from the squid. So you can see very sharp, but you know, microscopic. So it's just used to scrape and tear things at what it's doing. Now, moving on from there, finishing up the mollusks. Before we finish up with the mollusks, make sure you also watch the octopus video. It's really cool. We had a live octopus that you would have been able to interact with and play with. So moving on from there, we have got the annelids, right? So for the annelids, you've got three different big classes of them: the polychaetes, the oligochaetes, and the hyaridinias. So the polychaetes, they come in two main classes. You have the errant polychaetes and the tube-dwelling polychaetes. These are the Nereis, all right, that's the genus. These are just some of the errant or free-living polychaetes, meaning they're not, you know, they're not locked inside of a little tube like some of their cousins are, like some of the tube-dwelling ones are. And you'll see them moving around. Right? Note the parapodia with the setae. Right? So if you look really close, so the parapodia are going to be these fleshy appendages, kind of, you know, these soft little bits, and then the setae are the hair-like structures stretching off of those. Right? The definitions for all of those are more clearly in your manual, but apomorphes, parapodia with setae. Right? Parapodia is how you know you're looking at polychaetes. And right, so now you'll be able to see the movement of them. Ignore the video, the people talking in the background, so I turn it off. Right? But you can see, right, they're just kind of doing their worm thing, moving around. But they've got these parapodia and the setae and all that fun stuff going on. Moving some more. Okay, next one. So that was the errant polychaetes, some of the free-living ones. We've got some other families of polychaetes. These are the medusa worms, or the Terebellidae. They live in the bottom. I don't believe they're tube-dwelling, but they, you know, they bury themselves in the sediment and the sand. And you can watch. We put them in a little glass bowl with some seawater. Normally, they would be buried, and so from this section here, which hopefully you'll be able to see, that would be in the sediment, in the benthos, and all they'll be going out are these little tentacles, right? And they just scream across the bottom of the water. Sorry, they stream across the bottom of the benthos, just going out in every direction, looking for food particles, and then once they latch onto something, they curl up and they bring it back to the mouth, right? So the polychaetes, you got those parapodia with the setae, and then you also have these elaborate head structures. Not always going to be, they're not proper eyes, but just lots of things going on at the head, at the cephalic region of these things. So lots of stuff going on. So elaborate head ornamentation, whether it's tentacles or snapping jaws or whatnot, they're there. Okay, now we are at the ligochaetes. So common earthworm, classic example of what the ligochaetes are. You have things to remember for the earthworms or for the ligochaetes. They have a clitellum, setae, which won't always be visible, but you can feel it in your hands. Peristomum and prostomum, right? They are hermaphroditic. They share that with the leeches, the Hirudinias. So that means that they are both male and female, right? And that is going to be coming into play when you see the clitellum, right? That's labeled here, and that comes into play with copulation and how they do sexual reproduction and all that. The setae, not overly visible, but you can feel it if you put them in your fingers, which you would have done in lab. Prostomum and peristomum, all you really need to remember about those is that prostomum is this portion that is in front of the mouth, and peristomum is the section that contains the mouth. Stomum, mouth, pro in front of, peri with. Don't stress too much about what those actually mean. Just know that they're at the head end of the earthworms, and that one's in front of the mouth and one has the mouth. And earthworms, right? Moving on from there. Right, so for the ligochaetes, earthworms, right, we're going to, hopefully this video will play with the movement you can see. Right, and it's got that peristaltic movement. So your manual talks about this contraction of the longitudinal and the circular muscles in segmented order. So as you'll watch, the circular muscles constrict, right, and that squeezes it out, which makes the longitudinal muscles relax. Right, so when it gets skinnier, that's the circular muscles contracting and stretches it out. And then when the longitudinal muscles constrict, it gets fatter and it brings up the back end and helps push it forward. It's, they do have setae, which is very hard to see, but you can feel it if you were to hold one of these in your hands. You go from the head to the tail, mouth to the anus. It's smooth in one direction and a little bit rough in the other, and that's the setae you're feeling. That's the movement we're talking about, and I'll get there. So we got it zoomed in there again, so you can see that movement. Okay, now you're supposed to look at some cross sections, right, of the ligochaetes, and these are the cross sections we've been looking at. But here's all the important bits. Feel free to pause this and get a closer look so you can get an idea of what is going on. So just pause there so you can actually look at that. I'm not going to go too in depth in there. Hirudinia, everyone's favorite, leeches. So the Hirudo medicinales literally is the medicinal leech, and yes, they are still used in modern medicine. Why might you ask? Well, it's no longer for letting out bad blood as it used to be in the medieval times, but if you're doing microsurgeries, for example, reattaching a finger or something very delicate, and they need to prevent swelling, so they need to have the blood continuously drained because they're very, very delicate sutures. They have sterile medicinal leeches that are excellent at that because they prevent clotting of blood, and they just keep sucking away all that blood to give that microsutures time to heal before swelling would rupture stuff and cause all the damage. Things to remember about them in terms of apomorphies: they have a posterior body sucker. That's supposed to be one word there. So And then they have reduced or absent setae, so they're kind of smooth all around. If you're looking at a leech, the fat end is the butt, that is the posterior sucker, and the skinny bit, that is the head, right? Why would it be useful to have a posterior body sucker? Well, let me show you. So here we've got some of the medicinal leeches that we had in lab for you guys to look at, potentially play with. You'll see some of the movement that they exhibit is really cool. As you can see right now, they are latched on with that posterior body sucker onto the side of the jar. And then if we kind of give them a little shake, not only can they attach it to kind of inchworm themselves around while they find a place to latch onto their face and start sucking blood, but they can also swim, and that swimming movement, frankly, is quite lovely. Right? They were moving pretty fast. They didn't want to be filmed. But you can see them kind of moving around, right? So those are the medicinal leeches swimming in action. Again, so swimming around and doing their thing. So a lot of questions I've gotten emails. Hopefully the announcement I put out today, last night, whatever. So what we need to have, I need you to go through Blackboard and open up all the links and look at the material. Right, that'll be 5 points. And then pick 3 organisms of the stuff that's presented to you and give me 3 sentences per organism. Tell me something interesting, something important about them, apomorphy, something that you can see, something that you can identify. This is going to be in lieu of physical notebook checks, which obviously you won't be doing since all your notebooks are under my desk and we can't physically see each other. So, not looking for Encyclopedia Britannica, all right? Don't give me essays, couple sentences per organism. Give me something more than a high school. Don't tell me, leeches are gross, leeches suck blood. I know that, right? So take that, just 3 sentences, 3 organisms. So small little thing, 5 points. Submit that within 24 hours. So you got 1 day to do it. I'm going to go with 24 hours from the end of what your scheduled lab section time would be. So if you're in the morning section, lab is scheduled from basically 8 to 11. So by 11 a.m. on Thursday, I expect that. And then if you're in the evening section, since your lab is scheduled from 5 p.m. to 8 p.m., I'll be looking for those by 8 p.m. on Thursday. So 11 a.m. on Thursday for section 5, 8 p.m. Thursday for section 7. Please don't hesitate to email me if you've got any questions. I'm going to be trying to hold some Zoom meetings or office hours throughout Wednesday. But yeah, so thank you very much. And let me know if you got any questions or you need any more information on stuff, and be in contact. Thanks, and we'll get through this.